Hello YouTubers and fellow hams. Well, we're down here at the bench. It's evening, Sunday night. I really should be going to bed because I've got to get some sleep before work tomorrow. But I am just not tired. I took a little short nap this afternoon and I probably shouldn't have. And I was looking at the mini whip kit that John sent me. I think his name is pronounced John. It might be Jan, but I'm pretty sure it's John. That's what he said in the email. Anyway, and I thought, this is a real simple, not a lot of components on the main whip itself on this little board. Now, component side of the board, you can see we've got the RF transistor there, the J310 FET there. 3 1 meg resistors. Everything's nicely labeled on the board. 680 ohm, 100 nanofarad, 100 nanofarad, 100 nanofarad, 100 nanofarad, 100 nanofarad, 100 nanofarad, 2.2K, or 2K2, which is 2.2K, 10K, 47 ohm, and 470 microhenry inductor. So it's a real simple build. I got on the Dutch site looking for the schematic for this particular board in case it was different from the standard mini whip. Doesn't look like it is. They didn't have the schematic anyway. But they did say that the power draw, if you use the bias T board that they provide, which is a nice little PC board again, and I will probably build this up and put it in a little metal case. It's got a minimal component count on it as well. Not a lot of parts there. But if you use this and a 12-volt supply, it's supposed to draw 150 milliamps. And my eyebrows went up when I read that. 150 milliamps. I might have to find a heatsink for that little transistor at that current draw. That thing's going to get warm. But there's the parts bag. All the components are there. So, I think I'm going to build it. Now, enclosures. The ideal enclosure, which I will eventually put this in, is a piece of PVC, right? Put this in a PVC pipe, mount the BNC connector on the cap on the end of the pipe, put another cap on top, and you got a nice weatherproof enclosure for it, and you can put it outside up on a mast. And ground the coax at the base of the mast because it wants to work against the ground. This is basically an amplified RF probe. They got a small solder pad on this is the pickup area of the PC board here, and they got a small solder pad there that you could put an additional little wire whip on it if you wanted. I'll do some research on that, but I think I'm going to build up the kit as it exists. And just for testing, I don't have PVC presently, and I don't have the extra cash to buy it. I'm still waiting on that first paycheck from the job. So I mounted a BNC connector on a piece of wood. I like working with wood. So I got a little BNC connector mounted here. I'm just going to put a little double-sided sticky tape over here to hold the board in place after I connect it up so it doesn't bounce around. And this will just be my test bed because I'm going to test it using the bias T and the SDR play. So I am going to start populating this board, and got the soldering iron heating up over there. And we're going to build this little guy up. It shouldn't take long, maybe a half an hour to get all the parts on here and soldered. And then maybe I'll hook it up to the SDR play yet tonight, and before I go to bed, and see if it performs. So I don't know if you guys like watching me solder or not. I mean, it's not really very exciting. I'll probably turn the camera off here in a moment after I get a few components on here, and then come back to it with the camera after I get it built, and we'll test it out. But like I said, real simple board, not a lot of components. I'll go ahead and get the transistors on here. Everything's nicely marked. The silk screen shows polarization and identifying marks, so you can get everything lined up well. That stays on there nice and tight. Maybe I'll just go ahead and populate a few more components while I've got this going. My dad, when he used to build kits, he used to like standing transistors up off the board. And his reasoning was that they would run cooler. And I don't like doing that because if you stand a transistor up off the board like so, these leads have a small amount of capacitance between them. And especially in RF circuits, that can cause you problems, like oscillation and that. So I don't tend to do that when I'm working with RF. I'll get it down there, like so. And keep those leads as short as possible so we don't have to contend with extra capacitance there. So I'm going to populate a few of the components on here and then flip it over and solder it. All the caps, I think they are all the same value. 104, 104, 104, 104. Yeah, they're all the same value. 100 nanofarad, it's marked 104. So we'll just go ahead and, as long as they're not going to fall out, we'll just go ahead and populate a bunch of stuff and then solder it. Yeah, that's enough for now. Let's solder it up. Transistor, I'm going to do one lead, I'm going to go do another component, I'm going to come back and do another lead so I don't overheat the transistor. Let it cool between doing the leads. Oops. Oh. Solder pad doesn't want to take solder on that leg. There we go. Well, it didn't take all that long to get all the components on the board, about 10 minutes. And I'm pretty much done with the board. I just need to hook up a couple of pieces of wire to it for hooking up the BNC connector. Finish trimming these lead links off. And there is the completed mini whip. You can see all the components there. Everything in its place. Now there's two points here. One is marked out and one is marked ground. Now, out is the antenna connection, ground is the ground connection to the BNC, and also power comes in on the same antenna coax. So I'm going to get a couple of pieces of wire here. I'm going to use white for ground and red for the out and power. So we'll just strip these wires. And then we got to tin them. So clip the wires in here and we'll tin them. They're not going to be very long, so I am not too worried about the rest of the wire. Okay, so white is going to be ground. That's on this side. We'll put that in there. Solder's a little lumpy on there. To smooth that out. Okay, ground. And then out. Be red. Oh, again, I tinned that. Solder's a little lumpy on there, so let's smooth that up a little. There we go. Okay. Out. Alrighty. Now, where's my needle nose pliers? There we go. Okay. About that long. Just got to strip that. Now the ground is going to come over here to this, so we'll bring it at this angle, a little ways away from the antenna. About like so. So we're going to cut it about there. And we'll strip that. Now we just need to tin those. And that solder lug does not want to take solder. There it goes. All right, that's that. The mini whip is mounted and ready for testing. All built and soldered and ready to go upstairs and get hooked up. I've got a length of coax running over to a window. Where I had my home built version. So I'm just going to take this and I'm going to set it up there in the window, plug it into that coax. And that coax has a ground lead at that point. So I'll have a direct comparison between the performance of this one, the actual official mini whip, and the one that I built, which did work, just not very well. So we'll see what kind of a difference we see. So let's head upstairs and boot up SDR Play, boot up Cubic and the SDR Play, hook this up and see if it works. All right, initial results are promising. Definitely much better than what I was seeing with my home-built version. Now, bear in mind, I'm only biasing or supplying voltage to it from the SDR Play, which is 4.7 volts. I'm going to build up the bias T-board that came with it, put it in an enclosure, and feed it with a proper 12 volts, which should increase the gain even further. But with the 4.7 volts from the SDR Play, which is exactly what I was using with my home-built version, I want to do a straight comparison between the two. Performance is much better. Now, right now, I've got the Cubic SDR running. I've got it muted. It is configured as such. On antenna A, which I'm hooked to now, I have those rabbit ears that I built up. And they're extended to about 23 inches up in the window. So it's a pretty decent whip antenna. I want to compare as close as I can. So it's in a window. The mini whip is over in the other window. So they're both at the same level, sitting at the window pane inside the house. You know, I want to keep things similar. So on the rabbit ear whips, I'm presently on 40 meters. I'll unmute this. There's a couple guys talking. Well, here's another signal here. Let's go to this guy. I can kind of hear him. But now we'll switch to the mini whip. All right, I've got to find somebody who's still talking. Yeah, somebody stronger. All right. Decent signal. Let's go back to the rabbit ears. Wait till he starts talking again. Why do they always stop talking right when I need them to talk? All right.
She was there for the operation. She runs on the go-to station and tear down. And this is funny.
And that's the rabbit ears in the window. You can barely hear that guy at all. And here's the mini whip.
For all the ham operators. So we've been doing that for, I guess, 4 years now.
And just to prove that it's the whip, I'll turn off the bias voltage. Gone. So it's definitely working, and it's working pretty well. And now the other guy's talking. Let's switch to AM. There's an AM station up here.
Christian families were forced to flee Iraq, a number of Middle Eastern countries, when the Islamic State militant groups...
Mini whip. Turn on the bias.
Now about watching their children get left behind academically.
What a difference.
With few resources, local schools cannot take in large numbers of refugee children. A VOM
Rabbit ears.
decided to step in.
Much, 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 much weaker. So, the commercial mini whip is working a treat with only 4.7 volts. Now, if I build the bias T and I bring that up to 12, it's obviously going to be a lot stronger because that's going to increase the gain quite a bit. So that's the next step. But I think this is good enough for this video in comparing the commercial mini whip to the one that I built on the ugly construction on the board. Huge difference. Now, there's a couple of major component differences between the commercial version and the one that I built. I didn't have the 2N, what is it, 2159 or 1509, or I think it's 1509, the RF, the transistor that's designed for a low noise floor, high gain RF application. I didn't have one of those. I used a more general purpose NPN transistor for the amplifier in mine, which probably hurt it quite a bit. In fact, that might have been the actual problem with mine. I'll get one of those RF transistors and I'll change that out in mine and compare them again. But yeah, big difference. So there you go. The commercial mini whip works fairly well off of the built-in bias in the SDR Play. So I'll get around to building the regular bias T up and running it off 12 volts here eventually, and probably put it in an enclosure and mount it outside up on the roof or something, so it's got some elevation and is up away from the house a little ways, and probably use it for my main receiving antenna, because it certainly does seem to be working very well. Thanks for watching. If you enjoyed the video, don't forget to give it a thumbs up. Also, if you're not already a subscriber, click to subscribe. Join us on the Facebook channel for discussion about the videos, and if you'd like to help support this channel, please click to support me on my Patreon page.